Hello everyone and welcome to day 4 on chords and arcs. Starting off, we have the Chord Arc Theorem, which says that two minor arcs are congruent if their chords are congruent. So this also works backwards. If we have two chords that are congruent, then their minor arcs are congruent. If we have two minor arcs that are congruent, then we have two chords that are congruent. So this might look something like these two chords would be the same. So we would know that these two arcs would be the same because those two chords are the same, and those are the arcs that go with the chords. Next, we have the perpendicular bisector of a circle theorem. This one says if a diameter, which is the line that goes all the way through the circle through the middle, is perpendicular to a chord, then the diameter bisects the chord and the arc. So what this might look like is here is our diameter, and it is going through the middle of the circle, and it's going to cut this chord in half because it is perpendicular to that chord. It makes that 90-degree angle. So it cuts that chord into two equal halves. And since it cuts the chord into two equal halves, it also cuts the arc into two equal halves as well. The converse of this is if a chord is perpendicular to another chord, and this chord needs to go through the center of the circle. So another chord that goes through the center of the circle, then that chord is a diameter. Next is the equidistant chord theorem, which says if two chords are equidistant, equidistant means equal distance. It kind of sounds like an equidistant, equal distance. So a good way to remember that. So if two chords are equidistant from the center of the circle, then the chords are congruent. So the way we measure distance in a circle is we measure the perpendicular distance from the center. So here's the center of my circle right here. I put a pink dot at the center. The perpendicular distance to these two chords, here is one chord, here is two chords. I look at the center of the chords, and then I measure how far they would be away from the center using that perpendicular distance. So that's going to be the shortest distance to the center. And if that distance is the same, then the two chords are the same. And I know it's kind of hard to see with all the different colors, but those two chords are going to be the same. So some fun examples. Number 1, we have two chords that are the same measure, as you can see with the two lines. Since we have two chords that are the same measure, then their two arcs are also the same measure. So if we want to find the measure of MN, that's going to be this arc right here. First thing I'm going to need to do is I'm going to need to find Y. Well, those two arcs are going to be the same. So if this arc is 142, then this arc is 142. And this is in degrees, by the way. And a circle has 360 degrees. So if I go 360 minus 142 minus 142, I should get the remaining arc, which is MN. When I do that math in my calculator, I get 76 degrees is equal to MN. Number 2. I've got two arcs that are the same, so if this one's 132, then this one is 132. I also know that these two arcs, top and bottom, are going to be the same, which is good because this is the one I need to find. And this one, I don't know, but I know it's the same as the one I need to find, so I'm going to call them both x. Since I know that a circle should have 360 degrees, I'm going to set up my equation to go 132 plus 132, which are the two arcs that I know. And then I'm going to add in the two arcs I don't know, which are the same. And I'm going to have them all add up to 360 because it's a circle and they should all add up to 360. We are going to add our like terms. So 132 plus 132 is 264. And then x plus x is 2x. That's equal to 360. We'll go 360 minus 264. So minus 264 minus 264. I'm going to scoot over a bit. And we get 2x is equal to 96. I need to get x alone because I only want one of those arcs. I'm going to divide by 2. And I get x is equal to 96 divided by 2. Ooh, 48. Ooh. Now remember, x was mn, so mn is equal to 48 degrees. I answered my question that I needed to. Number 3. So number 3 is kind of a weirder one. I have a diameter right here. I need to find mn, so that's going to be this arc right here. Well, I also have this chord that is perpendicular to my diameter. So if I have a chord that's perpendicular to my diameter, then my diameter cuts that chord in half. So 2 equal halves there. Well, it doesn't just cut the chord in half, it also cuts the arc in half. So I'm going to say that this arc and this arc are the same. So if this top arc is 74, then this bottom arc is also 74. Now it kind of works backwards as well. This arc RM is going to be the same as MN. Whoop. So I'm going to call those both x again, and I'm going to set it up to have a similar equation as the one that I just did. So I'm going to go 74 plus 74, which are the two arcs that I know, and I'm going to add x plus x, which are the two arcs that I don't know, but I do know that this is a circle, so everything should add up to 360. We're going to combine our like terms. I got 74 plus 74 is 148. X plus x is 2x, and I have 360 here. We're going to subtract the 148, and I get, sorry, I have to move up. 2x is equal to 360 minus 148, 212, not 16, 12. Divide by 2, and I get x is equal to 106. So mn would be 106. The next examples are a little bit more algebra-y. So what we're going to do is just take it one problem at a time. We know P is the center of the circle. We need to find x, y. So I know zy, whoop, here is 3. I need to find xy, which is here. Couple different ways you could do this. The way I would do it is I would say, well, this triangle here on the top part and this triangle here on the bottom part are going to be congruent triangles. Now, how do I know that? Well, we have 5 ways of saying two triangles are congruent. We have side, 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 angle, 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 side, and then of course HL. Now, HL is not going to really apply in this example because we need a right angle, which we do not have a right angle, so it's going to be one of those 4. Well, I already know that this angle and those two triangles are the same. It is marked that they are the same, so they are the same. automatically, since I know an angle, I'm going to start focusing on one of the other options that uses an angle. Also, I know that PZ, this side, and this side PX are going to be the same because those are both radii in a circle. And since all radiuses in a circle are going to be the same length, those are going to be the same. And then my last side that I know is actually going to be PY. It's going to be congruent to itself. So since I know two sides in one angle, and that one angle I know is in between my two sides, I'm going to say that these two triangles are congruent by side angle side, which means that ZY and XY have to be the same. So XY has to be 3 because those are congruent triangles. Again, a little bit of review, a little bit of algebra. We got through it. Number 5. Number 5, first thing I'm going to do is I'm going to label everything. I know ZY is 6, which is going to be kind of hard to label, 6. And I know XW, which is this, is 4. Now, ZY, I'm going to break up into halves. Since I know that each of those halves is the same, I know the whole thing is 6, so each half is going to be 3, because half of 6 is 3. So this is going to be 3, this is going to be 3. I just broke up the 6 into 3 and 3. I, again, need to find XY, which is going to be that right there. And how I'm going to do this is I'm going to focus on this triangle that I just made right here. That is a right triangle, which means I can use the Pythagorean theorem to find my missing side. I have a squared plus b squared equals c squared. In this case, a and b are the two shorter sides, and c is my longest side, which is opposite my right angle. So this side that I need to find, xy, is going to be my c, which means that 3 and the 4 are going to be a and b. So I'm going to put 3 squared plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16, and it's equal to c squared. 9 plus 16 is 25, equals c squared. I'm not done though. I need to get rid of the squared on c squared, so I'm going to square root both sides. And the square root of 25 is just 5. So I've got c, no more squared because I square rooted it, which got rid of the squared. C equals 5. And remember, c was xy, so we have solved our question. Number 6, they tell us that the radius is 10 and that AB is 8. So AB is this full thing right here. I know my radius, which is this part, is 10. And again with the 8, I'm going to break it into halves because this is a perpendicular bisector. It cuts it in half. So this is going to be 4 and 4. Now, what I'm going to do on this is going to be a little bit tricky. I am going to create a right triangle because we're going to do another Pythagorean theorem. Now, from M to B, that is from the center to the outside of the circle, that is also a radius. So since this is also a radius, that means it is also 10. And now, this is the right triangle I'm going to use. This one right here that I just kind of drew in. This one. I know that this side is 4 and this side is 10. I need to find this part. So I'm going to do Pythagorean theorem. A squared plus b squared equals c squared. In this case, my hypotenuse, or my c, is opposite my 90, which in this case is 10. So this will be 10 squared equals, and a and b will be interchangeable. So I'm going to go 4 squared plus x squared, because that's the side we need to find. 4 squared is 16 plus x squared equals 10 squared is 100. Subtract 16. And I get x squared is equal to 84. Got to get rid of the squared on the x squared, so I'm going to square root both sides. And I get x is equal to, I'm going to put this into decimal form to make my life easier. So 84 square root The square root of 84 is 9.17, about, rounded. And that is only going to be this part, 9.17. I need x, y, which is this part. Well, I know that the whole radius needs to be 10. So I'm going to go 10 minus the 9.17, and that'll give me everything left over. I'll do that, and I get 0.83. So that would be our answer for x, y. This one is a bit easier. In the figures with the circles, circle J is congruent to circle K, and I know that MN is congruent to PQ. Those would be the arcs, and they did already mark those. So arc MN, arc PQ. I need to find line segment PQ. So it does give me some line measurements for these chords. It says that this chord is going to be 2x plus 1, and this chord is going to be 3x minus 7. First instinct is to find x. That's exactly what I'm going to do. Since these two circles are the same, and I know that those two arcs are the same, then I can conclude that these two chords are going to be the same by that chord arc theory that we did, or chord arc theorem that we did at the very beginning. So I'm going to say that those two arcs chords need to be the same. I'm going to set their two equations equal to each other, and I'm going to solve for x. Subtract that 2x over, and I get 1 is equal to 1x minus 7. I'm going to add 7, and I get 8 is equal to x. You might be tempted to stop here, but we need to find PQ. So I'm going to take the x that I just found and plug it back into that. 3 times x, which is 8, I just found out, minus 7. Well, 3 times 8 is 24, minus 7 is going to be, 17. So that is going to be PQ. Okay, last one. In circle H, PQ is 3x minus 4. Going to label that really quick. 3x minus 4. That's a 7, 4. And I know RS is 14. That's 14 right here. I need to find x. Now, this goes back to the equidistant chord theorem. These two chords are equidistant from the center. Here's the center. Here's the distance from the center. Both of those distances are 8. Therefore, those two chords are equidistant from the center. They are the same distance away from the center. So I can say that this chord PQ and this chord RS are equal. So PQ equals RS. Well, I also know PQ is 3x minus 4, and I also know RS is 14 based on what they told me right here. So now, using this information, I can solve for x. First thing I'm going to do is add 4, and I get 3x is equal to 18. Then I will divide by 3, and I get x is equal to 6. I was just asked to find x, so I am all done once I've done that. And that is it for day 4, so I will see you all again for day 5. Have a nice day.